Alright everybody, so here we have a fish hanging from a spring balance. We want to determine if it is accelerating upwards at 2.45 meters per second squared, and you have the balance, the spring scale, that reads 60 newtons. We know what is the true weight of the fish. And so we know the acceleration is 2.45 meters per second squared, and we know that the tension in the spring is going to be 60 newtons, because that's what the scale reads. What we want to know is what's the force of gravity of the fish. So the tension on the string points upwards, gravity points downwards. We can use the sum of the forces and set them equal to the mass times the acceleration. Just taking upwards to be positive, the tension in the string minus the force of gravity should be equal to the mass times the acceleration. And so here we're just going to solve for m. Remember over here on the right-hand side of the equation, you have numbers times m. Those are just coefficients. So it's 2.45 plus 9.8 m. It should give you 12.25 m. Divide by 12.25 and you get the mass of the fish, 4.9 kilograms. Now that we know the mass, we can determine the true weight by just multiplying times 9.8. You find that the true weight of the fish, 48.02 newtons. Now for part B, we want to determine when will the balance read 35 newtons. In other words, what acceleration of the elevator will lead to a scale reading of 35 newtons. To do that, we can use the exact same equation. And instead, now that we know the mass, we can solve for the acceleration. And so the acceleration is equal to minus 2.66 meters per second squared. So when the elevator is accelerating downward at negative 2.66 meters per second squared, then you'll have the scale, the spring scale, read 35 newtons. And so for the final part, we want to know what would the scale read if it was accelerating downward at negative 9.8 meters per second squared. All right, so the cable breaks in the elevator and it starts in free fall. What does the scale read? Well, again, using the same equation, the weight is just this mass times g. And if the acceleration is negative 9.8, then you find that these two will cancel out and the scale reads 0. The object is weightless if the cable breaks and the elevator is in free fall.